If it has the wrong machine identification or the wrong part number identification, you have a crashed robot. Somebody slipped up, forgot to change the part number on the automated system, and then bam, you have a crash. Okay, so when I say adaptability of new products, what do I mean? Let's think about an entire manufacturing line. You're a Ford, you're a Tesla, you're one of these big automotive manufacturers, right? These lines are tens of millions of dollars to develop and install. Well, if you can design a system and over-engineer the system, so that way as you have new model changes, it's very easy for you to adapt to a new model change. Or not even a new model change, maybe running multiple models on the same line. Because a lot of times, especially more back in the day, like only a certain vehicle could run on a line. Right? Well, why not design a system where you can run multiple products on that line? Let me just give an example. Like you want to run like a Ford F-150, you want to run a Ford F-250, a Ford F-350, a Ford 550, right? I mean, and now you're starting into much bigger vehicles, right? Where things are dramatically changing. To give an example is a lot of these lines, like could from a 150 to a 550, the line just literally couldn't handle it. Does not have the capability to do both. It has to be two separate lines. First thing. Second thing is you can make it to where you have to manually go in there and change a bunch of things, and maybe your changeover time is days, maybe 8 hours or something like that. Maybe it could be multiple days to change over. Or you can have this system designed in a way that literally you can change over in like minutes. Like the overall mechanisms of the systems can change over in minutes. Maybe it's robots doing auto tool changing. Maybe it's, conveyor track spacing able to separate because it's like servo-driven and can change, the conveyor width. Maybe it's, your fixturing positions and those being on servos. Maybe, and some things may still have to be manual, right? Maybe the cost is just too much that it doesn't make sense to make things completely automated, but you can do it as much as possible where your changeover time is literally like, especially in automotive, you can keep a changeover of an entire line to an hour or something. And this is something I think Tesla is doing extremely, extremely well. Here's what I'm envisioning. Not only they're designing their cars and they're designing their systems to be able to run any of their vehicles down the line, right? So when they make a manufacturing line, they're moving in a way that they can run the Model Y on it, they can run the Model 3 on it, they can run the Model X, the S, like pretty much all the things, right? And part of that is in the product design, right? They have to design like locating pins and different things like that are identical to the different vehicles to make sure that everything's located in the appropriate position. But the line also has to be capable to make its adjustments, right? When you go from a Model 3 to a Model X, the vehicle size changes enough that you definitely have to have maybe things like your locator pins, your robot positions. Everything's going to have to change vehicle to vehicle as far as a lot of that stuff goes. But just having the ability for things to auto change via servos and everything being recipe dependent, and instead of everything being a manual fixture changeover where somebody has to go in with nuts and bolts and change the thing over, because at some point, if it takes you 8 hours to do a changeover, unless you're doing a very low volume vehicle like a Lucid or something like that where they're making 80,000 vehicles a year or something, then something like that, maybe they can afford to do a manual changeover and then run, the Lucid Air and the Lucid Gravity. They can run both those vehicles on the same line because they just don't have enough production demand that they can afford to spend 1 or 2 days to change over the vehicle to run both vehicles on one line instead of having to procure a whole new automated system. So this is something that's on a mass scale, but there's a lot of operations where you can spend a little extra money in the over engineering and make a system much more adaptable. Let me give one quick example for bin picking. Say for instance you have a bin picking operation. Well, maybe you could extract a lot more ROI or just have more utility out of that system if you're able to move it to different locations and use that bin picking systems for different lines. Maybe this line's not running today, maybe it only runs 3 weeks out of the month, maybe demand became super high over on another area, and so you need something that's going to crank out 24 hours a day, whereas maybe you normally only run 2 shifts in a day, and you don't run a third shift or a night shift, or maybe you don't run weekends. And so maybe with that type of system, you would equip another vision camera that an RFID, so it can identify what machine it's connected to. You know, if there's a robot there, the robot can then identify its exact locationing to the machine, because even if you have mechanical locators from like the automated system to the machine, it may not locate exactly correct. So like that vision system would be something that can correct for that, make sure that every single time the robot like is placing in the exact same position. You could also have it so that the PLC automatically communicates with the automated system. So it's set up in that PLC where there's an identification between the two, where, you know, now the PLC knows there's not, the robot system is connected, and now the robot system knows what machine it's connected to. Like say for instance, we're talking about like stamping presses or something like that. You know, so now since it has that identification, they can literally receive the part information directly from the press's part number selection, right? Even in the automated system, you don't have to go and select a part number independently. So what I mean by that is you don't have to select the part number on the stamping machine and then go and turn and select the part number on the automated machine. Literally, you just change it on the stamping machine and it automatically changes to the robot as well. And why is that important? Well, going back into the example of like a robot crashing, if it has the wrong machine identification or the wrong part number identification, you have a crashed robot. Somebody slipped up, forgot to change the part number on the automated system, and then bam, you have a crash. And another method of doing that is you can use that same vision system to not only locate where it's physically at in space, but maybe also locate or identify like maybe some fixture or tooling that's in there, or maybe if you have a stamped part number or a nameplate there, you know, the vision system can take a picture of that nameplate and then retrieve the current running part number. So these are just different methods of how to go about, you know, engineering the system. I think there's a lot left on the table when it comes to over-engineering a system. I think that there's a lot of systems that get deployed as a budget system, and they actually don't end up being super successful. Like maybe they only get ran half the time, or maybe even like operators and maintenance just give up on it and they see it, or they just sit it back in the corner and to collect dust. And I've seen this a ton with collaborative solutions. So many universal robots and some of the CRX, you know, Fanix, any of the collaborative robots. It doesn't matter. I'm just mentioning some name. And the reason for it is because they didn't deploy enough technology into the system to make it robust enough that just an operator can operate it. They made it so that I'm going to have to move this machine move this automation from one machine to another. And the setup time and getting things worked out and working perfectly took so much work that it just wasn't worth it. Just send an operator there and call it done. They just give up on the system. And then, you know, when it comes to that, like the ROI of the system just completely depleted to almost nothing. So definitely over-engineering the system and making sure it has the proper technologies. It has proper robot reaches. It has proper tool changing, whether it's robot tooling or any other type of fixturing that's in the cell with it. Is it a mobilized automated system, or is it something where you have to unbolt everything from the ground and rebolt it to another location? You know, these are all different things to think about in the engineering of systems.